So in this video we're going to talk about Amdahl's law. Basically what it is if you have, say, 3 tasks, and let's say that the tasks, they take a certain amount of time each. So this one takes 10 seconds, this one takes 5 seconds, this one takes 5 seconds. So if you did it just as one stream, like in sequence, not parallel, then you would be left with 10 here, 5 here, 5 here, and that would take you 20 seconds. So 20 seconds is the amount of work. So it's work. That's the work that we have to do. So Amdahl's law says that the amount of speed up you can hope to achieve by adding parallelization is the amount of work over the span. So in this case the span is 10, because the span is the longest amount of the longest computation you need to do that has to be done in sequence, and in this case we can't parallelize this because it's just a database call that takes 10 seconds. So 20 divided by 10, so the best we can do is a 2 times speed up, which makes sense because you could have, instead of taking 20 seconds, you could have these two be done in parallel. So you have one thread doing the 10-second task, the other thread doing the 5-second task, and then once the second thread's done with the first 5-second task, like it finished that, it can start doing the second 5-second task, and then by the time the 10-second one's done, all these will be done. So it will be done in 10 seconds instead of 2. So that makes sense. Alright, so let's start coding this up. So the first thing we're going to need is a class for the, let's call it task wait. So all we're going to do in this is wait for a certain amount of time. So for recursive actions, you have to extend the Java class recursive action, and it comes with a method called compute. So we'll just go ahead and implement that. And so what I want to do is I want to pass a long millisecond wait to the constructor. So I'll create a private variable there, public task wait, takes in one variable, mswait, the amount of time we're going to wait for this task. We'll say this dot mswait equals mswait, and then all we're going to do in the constructor is we're going to say thread dot sleep, and then mswait, and this dot mswait. So the way this, and then we have to supply a try catch. So the way this thread.sleep is thread just gets the thread that this program is running on. So if we multi-thread, then we'll have 2 different threads according to the last picture. So that thread that we're working on will sleep for a certain amount of time, so it won't do anything, which mimics talking to a database or something you want to do. Alright, so now we'll create a runner class for Amdahl's law. Call it Amdahl's law. Okay. So what we're going to do here is first we're going to create them all and run them sequentially. So to do that, we're going to, what should we do? Actually, let's just do public. Yeah, let's make the runner class main. Public side void main. Taking string. Regular cards. That's how you set up a Java class. Alright, so the first thing we're going to do is let's make a helper function, because I know for a fact that every time you run a compute on a async task, and it basically destroys itself, and I want to run it twice, so I have to make a private function that returns me a list of task waits that are just new task waits. I have to import that. Get fresh list, I guess, and takes no parameters. And all we're going to do is return new array list, and we're going to instantiate with arrays dot of, or wait, dot of as list. Okay, and then we're going to do new task wait, and we're going to pass it 500 milliseconds. New task wait, another 500 millisecond one, and new task wait 1000 millisecond one. Okay, so this won't be 10 seconds, 5 seconds, 5 seconds. It will be 0.5 seconds, 0.5 seconds, 1 second. So it should run in about 2 seconds, and that's a little fast. Yeah, you probably see the difference. So let's do sequential. So what we want to do is we want to have a long for work. We'll substantiate that later. And then we're going to say our list. Nope, don't want to do that. List of task wait and tasks equals get fresh list task. Where to go? You know what? I have to do private static because you can't call non-static methods in a static function. Okay. Alright, so this gets the fresh list. And then what we're going to do is we're going to say first we need to start the clock. So we're going to say long start time equals system current time millis. Now we're going to do the function. So now compute. So for task wait, wait, and I imported concurrent task. I don't want to do that. Alright, so for task wait, and then it is task in tasks. We're just going to do task dot compute. So that just runs it sequentially. And then what we're going to do is we're going to system dot out print line. We're going to say work equals what is work equal? Work equals right start time minus right minus no it's sorry system I have to do uppercase system dot current time millis minus start time because yeah, there we go. And then we'll say work just hold the thing. There we go. Alright, so that should do it. So let's just try this out. It should be about 2 seconds. Just building. Nope, and what did I do here? I forgot that. Okay, let's try it again. Two seconds, 2000 milliseconds, so 2 seconds. Alright, and that's good. So now let's do parallel. So long paric, just call that. Yeah, and then we're saying tasks, and we want to get fresh list because we can't rerun recursive tasks because or recursive actions because they only run once. And then we say long par start time equals system dot current time millis. Then we want to say alright, now we're just gonna so forking is basically creating a new thread and starting running. So for task wait task in tasks, we're going to say task dot fork. So we're going to give it to a new thread and say, hey, run this. So then after we're done forking, we're going to have to join them back together. And joining blocks. So blocking basically means the 500 millisecond one finishes, gets to this part, and then it waits. And the other 500 millisecond one gets this one, it waits. They might do it in parallel. And then they'll both wait until the 1 second one gets here, until they go on after this blocking spot, which is just, it's tasks out join. So I'll show you right now. It's just for task wait, task and tasks. We're just gonna call task dot join. I'm gonna sneeze. Or not. So basically it just blocks right here. So the 500 milliseconds ones will wait for the 1 second one here until all of them hit this task join, and then down here we're back down to just one thread because they all just merge back into one thread. We're just going to system.out.println par work, and that's going to be equal to par work equals system.get current time millis minus par start time. That's our parallel work, and then predicted speed up is 2. So let's print out the actual predicted speed up. So it's prism.out.println speed up, and that will be equal to work. And then let's convert that to double, so times 1.0 divided by span, or not span. So par start time is, no, not par start time, par work. There we go. And the reason we do 1.0 is to convert to a double so we can get decimals. Right, and that should be good, so let's run that, see how it works. Okay, so we got basically a 2 times speed up, and the reason it's not exact is there's some overhead with creating parallel threads, but it's very minor, where there's some overhead in this code, which is 27 milliseconds or 23 milliseconds, not even, yeah, about. So it's pretty minor difference, and that's so that's Amdahl's law with recursive actions.